So the first book which we are gonna cover is this Linux Command Line by William Shard. This is an open source book. It is in the Linux Command.org, and they have this free PDF version to download as well. I think this is the first book I am thinking of covering because if you wanted to go as deep as kernel level of Linux, first you got to understand just the basics of Linux. So I use Debian as my daily driver. So I use Linux commands on my day-to-day basis, but still there are a lot of parts which I need to brush up or learn new. So this is the only book which I think I would like skip the most the easiest parts which I already know, like moving from one directory to another and stuff like that. And because there are a lot of things to cover, this book is about 530 pages. So I'm thinking of skipping those parts and covering most of the other parts. Let's get started. So the Linux command line, the second edition, William E. Shorts Jr. Cool. Okay. I think we'll do the introduction first. There are some parts which I'm gonna skip, like navigation. These are very basic stuff like understanding the file system tree and relative path, absolute path in Linux systems. And I think the topic which are very rudimentary, I think I would skip them. And most of the other parts we will read through. Like example, this is all very straightforward. Like how do you CP, MVRM, and all of this. But links are very important to understand, like hard links, symbolic links, and all of those things. So all those things we would explore. And if something is not very clear, we can like go and figure out some other resources and make sure we understand those parts. Because if you are from the C world like me, you might have understood by now what is the symbolic linking and what is hard linking, but we will read through and try to understand all these pieces. Let's get started. Introduction. I want to tell you a story. No, not the story of how in 1991, Linux Torvalds wrote the first version of the Linux kernel. You can read that story in a lot of Linux book. Not I'm gonna tell you the story of how some years earlier Richard Stallman began the GNU project for Linux like operating system. That's an important story, but the other Linux books have that one as well. No, I want to tell you the story of how you can take back the control of your computer. When I began working with computer as a college student in the late 1970s, there was a revolution going on. The invention of a microprocessor had made it possible for ordinary people like you and me to actually own a computer. It is hard for many people today to imagine what the world was like when there is no big business or government ran all the computers. Let's say you couldn't get much done. Today the world is a different place. Computers are everywhere. Blah blah blah. This has created a wonderful new age of personal empowerment and creative freedom. Something else has been happened. A few giant corporations had been imposing their control over most of the world's computer and deciding what can and cannot do with them. I think they are hinting about Microsoft. Fortunately, people from Microsoft and Mac, maybe even Mac is on top of Unix, right? But little, still it's proprietary. But I think they are talking about Microsoft here. Fortunately, people from all over the world are doing something about it. They're fighting to maintain control of their computer by writing their own software. They are building Linux. I've been using Debian for over like 2-3 years now, and it is fine. I have no big problem. Many people speak of freedom with regards to Linux, but I don't think most people know the freedom really means. Freedom is the power to decide what your computer does, and the only way to have this freedom is to know what your computer is doing. Freedom is a computer that is without secrets, one where everything can be known if you care enough to find out. Why use the command line? Yeah, I have the same question. It for me, once I got used to command line, it becomes a lot easier to navigate. Basically, because Debian's, I use KDE for my desktop manager, and KDE is little off. It is not very easy to navigate, and command line is easier because whenever I use Mac, I use half of the time Mac and the other half Debian stable. So it is very easy for me to just use command line. And after a point of time, command line is I started to prefer command line over no web, even for GUI, even for like basic copying on all the most of the stuff. The only thing which I don't use command line uh, is very even difficult to think for what. Maybe I don't know, like opening a file. Yeah, opening a file. I would use the GUI and try go open the file. Other than the opening, reading the file and all those things. Other than that, even editing a file, I don't use a editor. I use Vim, so directly I open it via Vim and then edit. But mostly opening the file, I use command line. I don't use command line. I noticed in the movie when the super hacker, okay, break into sits down at the computer but never touches a mouse, because the movie maker realized that as we human being instantly know the only way to really get anything done on computer is by typing on the keyboard. Uh, Most computer users today are only familiar with GUI and has been taught by the vendors and pundits that CLI is terrifying thing of the path. Again, Windows. This is unfortunate because command line is marvelous expression way of communicating. GUI makes it easier while command line interfaces makes okay difficult task possible, and this is very true today since Linux is modeled after using Unix family of operating system. It shares the same rich heritage and commands tools as Linux. Unix came into prominence during the early 1980s, although it was first developed a decade earlier. Before the widespread adoption of the graphical user interface and result developed an extensive command line interface instead. In fact, one of the strongest reasons early adopters of Linux chose it over, says Windows NT, was the powerful command line interface that made the difficult task possible. Okay. Unlike some books where they concentrate on single programs such as shell, bash, this book will try to convey how to get along with the command line interface in a large sense. How does it all work? What can it do? Okay. This book is not a Linux system admin. Okay, the purpose of me picking up this book is it's not a sysadmin's perspective book. There are better books that are sysadmin purpose, but this is general purpose because once no, I fill up the general purpose knowledge graph. Like I don't use a lot of network related commands here, that TCP dump and IP config. Just IP config that uh, to see IPv4, I think it is minus E something, 5, something like that. E105 or something like that. All those commands I don't actually use. I don't know by heart, and I need to Google and understand, try use them. So all those all those things, I think I need to fill those gaps. I think that's why I picked this book as the first book, because since it is like 500 page and I already know about 200 to 50 pages concepts before itself, it will be easy for me to get through the first book. This book is very Linux centric. Many other books try to broaden their appeal by cluttering other platforms such as Unix or OS X. By doing so, they water down their content to feature only general topics. This book, on the other hand, only covers contemporary Linux distribution. Okay, 95% of this content is useful for users of other Unix-like systems, like I think Mac. But this book is highly targeted to modern Linux Linux command users. Who should This book is for new Linux users. Okay. There is no shortcut for to learning this command line is challenging and takes real effort. I think the best tip for me I think the reason why I picked up Linux very easily is no large part of my time goes in debugging in servers, but because I had a Mac and I started using the command line, and the transition is very smooth from Mac to Linux over when compared to Windows to Linux. Because from Windows to Linux, it's just night and day change. But from Mac to the full on Linux, it is I think it is an gradual transition because you start using all those command line tools in Mac if you are interested, and then you could transition to Linux completely. Has literally thousands of programs that you can employ on the command line. Consider yourself one. Learning the command line is not a casual endeavor. Okay, learning the Linux command line is extremely rewarding. If you think like a power user, just wait. You don't know what real power is yet. And unlike many other computer skills, knowledge of the command line is long lasting. The skills learned today will be useful 10 years from now. The command line has survived the test of time. It also assumes that you have no programming experience. Okay, we'll start down from that path as well. Okay, let's see what is in that book. The material is presented in a carefully chosen order, like a tutor sitting next to guiding you along. Many authors treat this material as a systematic fashion, which makes sense for the writer's perspective, but it's not. It can be very confusing to the new users. Another goal is to acquaint you with the Unix way of thinking, which is different from the Windows way of thinking. So the thing about Unix way of thinking is there are like a bunch of Unix principles, and if you know that principle, if you understand that principle, like I'll give you an example. Treat everything as a file. That is one of Unix principle. So you can take that principle and apply it to software development as well. When you're designing systems, you could use these Unix principles. A lot of systems which exist now are derived from these Unix principles only. You can use these principles and build software. Like you can build systems, you can build distributed systems, and these skills are very transferable. That is another reason why I'm picking Linux and things around Linux as my first few books. Along the way, we'll go on a few side trips to help you understand why certain things work the way they do and how they got that way. Linux is not just a piece of software, but it is also a small part of a larger Unix culture. Okay. So the part one is learning the shell and configuration, and the environment covers editing configuration. Okay. Common tasks and essential tools. Many of the ordinary tasks that are commonly performed from the command line. Unix like operating systems such as Linux contains many classic commands that are used to perform powerful operations on the data. Writing shell script. I think so. I would skip this because I can write a decent bash, but we'll see. How to read this book. Start from the beginning of the book and follow to the end. This isn't writing as a reference work. It is more like a story with a beginning, a middle, and end. Cool. Install Linux. I use Linux as my daily driver. Regardless of how you install Linux, you will need to have an occasional super user. Okay, I am the sudo user. Why I don't call it as GNU/Linux? In some quarters, it is politically correct to call the Linux operating system as GNU/Linux operating system. The problem with Linux is that there is no completely correct way to name it because it was written by many different people in the past in a vast distributed development effort. Technically speaking, Linux is the name of the operating system kernel and nothing more. The kernel is very important, of course, since it makes the operating system go, but it is not enough to form the completing operating system. And Linus Torvalds just works on this kernel. Remember that. Enter Richard Stallman, the genius philosopher who founded the free software movement started Free Software Foundation. It is still prevalent. Free Software Foundation formed the GNU project, wrote the first version of the GNU C compiler (GCC), created the GNU General Public License, etc. etc. He insisted that you call it GNU/Linux to properly reflect the contribution of the GNU project. While the GNU project predates the Linux kernel, and the project's contributors are extremely deserving to the recognition. Placing them in the same name is unfair to everyone else who made a significant contribution. Besides, I think Linux/GNU would be more technically accurate. Okay, Linux first, GNU next. Here is a GNU first and Linux second. Okay, would be technically accurate since the kernel boots first and everything else run on top of it. Cool. Yeah, because first the kernel will boot, right? Only then you have this GNU. In popular usage, Linux refers to the kernel and all the other free and open source software found in the typical. Okay, Linux is kernel and the free software. That is the entire Linux ecosystem, not just GNU component. The operating system marketplace seems to prefer one-word names such as DOS, okay, Solaris. Next, I have chosen to use the popular format. If, however, you prefer to use GNU/Linux, please perform a mental search and replace while reading this book. Cool. I don't care. Let's see. That's okay. Additional reading is about Linux stalwarts, Richard Stallman, a free software, GNU. Cool. Okay, I think let's. Start the uh, part one. There are some parts I think I would skip, but let's see. What is a shell? Okay, I have my notes set up in. Okay, when we speak of the command line, we are really referring to the shell. The shell is a program that takes the keyboard command and passes them through to the operating system. Okay, distribution supplies a shell program from the GNU project called Bash, Born Again Shell. Okay, so all Linux distribution from GNU project uh, gives a shell that is called Bash. So Bash is an acronym for Born Again Shell. Okay, so the fact that Bash is an enhanced replacement of SH, the original Unix shell written by Steve Bond. Okay. Even when you and I write notes, I still use SH only. But okay, so it is nothing but you. Okay, we can do that. So I'm trying to open my terminal. I use Ghosty as my terminal. You can use whatever. So this whole interface is shell. You can use different version like Mac has something called Z shell, which you can reset to this bash as well, or you can use the older version of SH as well. An upgrade of SH is the bash. make copy bash. So bash is nothing. So bash is nothing but. So bash is nothing uh, but a program which takes the user input and passes them to us. Okay. So terminal emulator. When you're using a graphical user interface, we need another program called terminal emulator to interact with the shell. If you look through our desktop menu, we will probably find one. Okay, since fortunately I use KDE and there is something called console. Let's see, search menu, KON, you see console. So this is what they call as terminal emulator. I extensively use a terminal emulator called Ghosty, which is created by one of my idols, Mitchell Hashimoto, who is the founder of HashiCorps. And Genome has so what is KDE and Genome? So KDE and Genome are if you are into Linux world, you will understand. You will know that. So what I'm running now is Debian stable, but the Debian stable doesn't have an desktop environment on top. That desktop environment is the KDE here. Genome is another variant of no desktop UI where if you install Ubuntu, you will see this genome. Genome is very closer to genome is better. Some people say genome is better than KDE. KDE is better than genome. But I am using KDE for over 2 years now, and I have no problem. But genome is more popular because its style is a lot similar to because it is in Ubuntu, and Ubuntu is the widely used distro. Genome is by default in Ubuntu, and it looks very similar to uh, the styles are very similar to Mac, so that's why it is a lot more popular. Although it is likely called as terminal, yeah, there's a number of other terminal emulators available for Linux, but all are basically do the same thing. Give access to the shell. Okay, let's see. Launch the terminal emulator. Once you come up, you should see something like this. Yes, we did see that. This is called a shell prompt, with and it will appear whenever the shell is ready to accept input. While it may be vary in appearance, okay, depending upon the distribution, you will okay, username at machine name. You can see here what is the username. I use a Dell XPS 13, so that is the machine name. If the last character is of a prompt is a pound sign rather than a dollar sign, the terminal section has an okay, I didn't know this. So, since there is a dollar means it's not a privileged environment. Then, if I'm in a pseudo administrator environment, it will be a pound sign. So, it is saying that if the last character of the prompt is a pound sign rather than the dollar sign, the terminal session has super user privilege. This means that either we are logged in as a root user or we selected the terminal emulator that provides super user privilege. Cool. This is something which I didn't know before. Okay. Assume that things are good so far. Let's time terms. Okay. It says command not found, command history. Okay. You just press the up arrow, you will see a bunch of command history. There is another way also. You can use command R to search also. This is way more common. Like you could search through, suppose you want to go to 10 commands before, instead of this, you could directly do a command R and do fuzzy search to that part. Okay, cursor movement. That's okay, okay. Okay, while the shell is all about the keyboard, you can also use a mouse with your terminal eliminator. Okay, this is fine. Don't be tempted to use Control C and Control V to perform copy paste. They won't work. Yeah. So it is Control Shift V. It is not Control V. It is Control Shift V. Control Shift. The graphical, mostly likely KDE or Genome. Oh, glad they wrote this book considering KDE, because I don't know a lot of people who use KDE, but since I use and this book talks a lot about KDE, it's like easy for me to follow along. So if you ever wanna read this book and if you don't have a Linux machine or if you use a Windows, you can create a virtual box, which is a virtual environment. There you could install Ubuntu or Ubuntu. Don't install Debian stable. It is a lot difficult process. We are not using a using it as a daily driver. You can like install Ubuntu and then like try this out. And that is even more easier, because if you crash something, if you don't understand, like if you do, there is something called rm minus r of star. It's a meme, and if you do something like that also, you could get away. That won't work, but it's a meme. That's okay. Okay, you have a date command which just shows you the date. You can use cal, displays the calendar of the current month. Cool. Df. This is very important command which I keep using it. Df. So it just shows all the drives available. Free is like all the free memory. Ending the terminal session is exit. You can use Control C. Even if you have no terminal eliminator running, several terminal sessions continue to run behind the. Okay. You can access on most Linux distribution by pressing Control Alt F1 through Control Alt F6. When the session is accessed, it presents a login prompt to which you can enter a username and password. Okay, cool. I think we are in the part. We've completed the introduction. We've completed what's in the shell of part one. Now we'll do the navigation. I think navigation we can like skip a lot. I think PWD, CD, LS. We'll go something. Okay, I will quickly explain what are all these. PWD is current working directory. Suppose I am currently in the root. If you want to check where I am, you can use PWD. Then you will see this is the current path I am home void, and then what they're doing CD. Okay, so first there's something called ls. It will list all the files in the. It will list all the files. It will list all the files in that directory, and then you can use CD to literally change directory to go to wherever you want to. ls will list all files. If you wanted to list hidden files, it is ls minus k hyphen a. So an absolute path will start with direct slash. It is not dot slash, direct slash. And relative paths will have dot here. Cool. And if you do dot dot, it will go one step behind. Anything interesting? Okay. I think this is very straightforward, very rudimentary. Let's see. I think we will go with this. Okay, so this is also one command which I commonly use, ls minus l. What happens is it shows in a more clearer format, and this is the user group, read, write, and execute, and you can read the user group to understand what are all the privilege the current file has. So if you put that file in a certain group, it will have certain privileges. That's what means by this. So minus L will be like this. I use something called ls hyphen lhtra. Human readable tr. A is for hidden files. R reverse and hidden files, and it'll show like this. I think this is something which I use. And a lot of things that you could, there is something called man pages, which is manual, through which you could easily learn about whatever commands you want. There'll be this slash help, and then you could see all of the command. Minus a is all including hidden directory, minus f classify, human readable. That's why I use this combination lhtra. T is sort by modification time, reverse, display in long format. Yeah. Okay. This is the one. So you, if you could look at that after entering LH minus LSTRA, you could see this. What is this? The access where you could see this. This is write. This is read. You could understand the. So access the. So what does this mean? Access write to the file. The first character indicates that the type of file. Among the different type, a leading dash means a regular file, while a D indicates a directory. Cool. This is a regular file. It is not a directory. The next three characters are the access right for the file's owner, and the next three. So this three, and then the next three for the files group, and the last three are for everyone. And it says that the full meaning of the discussed in chapter 9 permissions, because this is very important, because sometimes you write some bash script, and if you, yeah, it'll give you some permission, a permission error, and then you should do that chmod and give that executable permission. Once you see these fields, and then you will understand that the file was missing with the executable permission, and after giving that executable permission, you will be able to execute that file. Okay, you can use, as we explore the system, it will be very useful to know that what file contains. To do this, we will use the file command to determine file type. So file name, it will give us the file type. Okay. The less command is a program to view text files. Throughout a Linux system, there are many files that contains human readable text. The less program provides a convenient way to examine them. So, okay, what is text? There are many ways to represent information on a computer. All method involve defining a relationship between information and some number that will be used to represent it. Computer, after all, only understands number, and all data must be converted into numerical representation. Some of these representation system are very complex, while the others are rather simple. One of the earliest and simplest is called ASCII. ASCII is a short form of American Standard Code for Information Interchange. This is a simple encoding schema that was first used on teletype machine to map. So technically, what they're trying to say is, So there'll be a bunch of numbers, and for each numbers you will map that with the corresponding letters, and these numbers can be represented as binary numbers. So binary number to a number and the number to ASCII. So and then the size of that binary depends. It can be hexadecimal, it can be 8 digits, it can be a bit size, it can be hexadecimal, it can have 4 bits, it can have 16 bits, and all those things. So cd into a directory, list the files, blah blah blah. This is all very simple. If you are using a mouse, you can double click on the file name too. Okay, if you are using a mouse, you can double click on the file name to copy it, and middle click to, what is that? Let's say I'll just go to some folder. So I double click, and what is, oh cool. So what is happening is, so in my mouse you can, I just double clicked it to copy that name, and this scroll bar is there, right? The scroll bar, if you click on that scroll bar, you're able to paste it. Suppose I will do this. So double click and then the scroll bar, double click, and now to paste I click the scroll bar and paste. I had no idea. This is the first time I'm mind blown. It used to be I would select the word and then copy, but this is slightly easier. Okay. Remember, in Linux there is no secret. Okay. Directories slash is the root directory. Bin contains binaries that must be present for the system to boot and run. Slash boot contains the Linux kernel, initial RAM disk image, and the bootloader. Okay. A boot grub got config on menu dot or menu dot lst, which are used to configure the bootloader. Slash boot VM lins the Linux kernel. This is a special directory which contains device nodes. Everything is a file. See, this is a Unix principle. Everything is a file. Also applies to devices. Here is where the kernel maintains the list of all devices it understands. So in Unix, what they're trying to say is, in Unix, everything you do will be part of a file, like the networks, something you do with related to network, something you do related to config, everything will be part of a file. So they would append in the file, remove that file, delete that file, and everything will be part of the file. /etc. So /etc is a very important folder because if you are familiar with writing cron jobs and systemd timers, then you would know about /etc, because that's where you write the cron tab in there. This is a directory that contains all the system-wide configuration file. It also contains a collection of shell script which start and end the system service at the boot time. Interesting files. So what they're saying is, there are certain number of files which needs to run every single time, and those files are there in the etc. So a kind of timer is being scheduled, and it's picked up and it's been run again and again. So etc/cron tab is a file that defines automated job to run. FS tab, a table of storage device and their associated mount point. Okay. So list of user account. Slash home is the normal home. Slash lib contains shared library files used by the core system programs. These are similar to DLLs in Windows. Okay. Lost plus found. Each formatted partition or device in the Linux file system, such as ext3, will have this directory. Okay, it is used in the case of a partial recovery from the file system corrupt event. Okay, unless something really bad has happened to your system, this directory will remain empty. Okay. On modern Linux systems, slash media directory will contain the mount point for removable media such as USB drive, CD, RAM. Okay, cool. Okay. In older Linux system, the slash mnt directory contains mount points for removable devices that has been mounted manually. Okay, in older Linux system, slash mnt. Okay, OPT directory is used to install optional software. This is mainly used to hold commercial software product. So and if you use so many distros are on top of Linux kernel and they utilize all these features, but they write a spin of it. Example, if you use a Nix OS, everything is configurable. Remember that. Used to install optional software. This is mainly used to hold commercial software products. Okay. Proc. The proc directory is special. It is not a real file system in the sense of files stored on your hard drive. Rather, it is a virtual file system maintained by the Linux kernel. Okay. The files it contains are peephole into the kernel itself. Okay. The files are readable and when you give you so and will give you a picture of how the kernel sees the computer. So another thing is all these kernel codes, right? Eventually, in the second book or third book or somewhere, we would build that from scratch. At that time, we can explore all these files. That's why I'm not like directly going to that file and playing around. And largely, I've seen those files, but we there are books which I picked which extensively goes into all of these so that we could learn. Root directory sbin. This directory contains system binary. These are programs that perform vital system tasks are generally okay. Slash temp is temporary directory. I can understand. Slash user is user directory is like to be the largest one on the Linux system. It contains all the program and support files. Okay. Contains executable. Okay, installed by your Linux distribution. It is not uncommon for this directory to hold thousands of program. Okay. User library will exactly same. It was this sbin local lib bin. It was exactly the same lib and all of those things. But now the scope is to the scope is the user scope. The user directory tree. The user directory tree is likely the largest one on the Linux system. It contains all programs and support files used by regular user. Okay. The user bin contains the executable programs installed by your Linux distribution. It is not uncommon for this directory to hold. Okay. Is were not included in your distribution but are intended for your system-wide installation. Okay, correct. Programs compiled from source code are normally installed in user local bin. Compiled from the source code. Okay. On a newly installed Linux system, this tree exists but will be empty until the system administrator puts something. Okay. I understand. With the exception of slash temp and slash home, the directories we have looked so far remains relatively static. That is, their content don't change. The var directory is where the data that is likely to change is stored. Okay. Cool. Contains log files, record of various system activities. These are very important and should be monitored from time to time. Okay. Cool. Now let's see symbolic links. as we look around, we are likely to see a directory listing with an entry like this. LRW X is executable, RW read write executable read. Okay, one root. Okay, this is what we call it symbolic link. Okay, notice that the first letter in the listing is L, and the entry seems to have two different file names. This is a special kind of file called symbolic link, also called a soft link or symlink. Okay. In most Linux based system, it is possible to have a file referenced by multiple names. Okay. It is possible to have a file referenced by multiple name. Okay. While this value of this may not be obvious, it is really a useful feature. Okay. Picture this scenario. A program requires the use of a shared resource of some kind contained in a file name foo. Okay, the program requires to use our shared resource. Okay, so contained in a file name called foo, but foo has frequent version changes. Okay, it would be good to include the version number in the file name, so the administrator or the other interested party would see what is the version of foo is installed. Okay, this presents a problem. If we change the name of the shared resource, we will have to track down every program that might use it and change it to look for we may need to use it and change it to look for the new resource name every time a new version of the resource is installed. Correct. This doesn't sound fun. Okay. Oh, why are they writing in this way? Okay, I understand that. Okay, here is what symbolic links say every day. Let us say we install a version 2.6 of foo, which has the file name foo 2.6. Okay, then we create a symbolic link simply called foo that points to foo 2.6. Okay, this means that when a program opens the file foo, it is actually opening the file foo 2.6. Now everybody is happy. The program that relies on foo can find it, and we can still see what actual version is installed. When it's time to upgrade to foo 2.7, we just add the file to a system, delete the symbolic link foo, and create a new one that points to the new version. Okay. Wait. Creates a new one points to the. Now only does this solve the problem of version upgrade. Okay, but it also allows you to keep both the version on our machine. I understand, but I don't understand the deletion. So you have a symbolic link, and you link to 10 different files, and you can have a newer version, and both version can be there in the same machine. That is fine, but how does now the program when relies on foo can find it, and we can still see what is the actual version it is installed that rely on foo. Okay, upgrade, we just add the file to the system. Okay, delete the symbolic link foo. Okay, and create a new one. Technically that link will be a new link. That's what is it what he's trying to say. So you just change the version number and still everybody is linked. Is it something like that? Create a new one. So this new one is again, if it is technically correct, then the new one will also be foo. So there won't be any problem. I think that is what he's trying to say. Not only does this solve the problem of version upgrade, but it also allows us to keep both version on the machine. Okay, imagine that foo 2.7 has a bug and we need to revert to the old version. Again, we just delete the symbolic link pointing to the new version and create a new symbolic link point to the old version. The directory listing above, first a symbolic link, okay. For libc so 6 that points to a file called libc6 2.6, so that points to one shared library file called libc 2.60. This means that the program looking for libc6 will actually get the file. Wait. Hard link. While we are on the subject of links, we need to mention that there is a second type of link called hard link. Hard link allows file to have multiple names. Okay, they will talk about. First, I have doubt in the symbolic link. So I think I understand, but the text here is not very clear. We will just Google it and see. Okay, cool. We are exactly correct. The book is like the wording is slightly uh, problematic. So let's say you have two different programs, program A and program B. It's at two different location. And let's say this file is called ABC. Okay. Let's say this file is called ABC version 1. Let's think like okay, this is called ABC version 1. So now let's assume that both this program needs to be using this ABC version A for running. Let's assume that it's some kind of an header file for both this program. It will be even easier. So let's this program A and program B needs this both program A and program B needs this ABC version to run. So what you can do is the easiest way is directly reference this file here, so that now both program A and program E is using this ABC version 1. But if there is a version upgrade, let's say this ABC version 2, there is this ABC version 2. Now what I need to do is, here it is two programs that can be like 20-30 different places it has been referenced. I need to go to all those places and change its reference from ABC version 1 to ABC version 2, so that it points to this now, not the ABC version 1. So there are two places where you need to change. One is the change of the version, the newer file, which is obvious. Another is you need to go to all the places to make the change. How can you solve this? You can solve this with this soft link. So you see here, you can solve this with this symbolic link. So what you can do is, now you create something, you create an symbolic link called DF, or I'll say XYZ. XYZ is clear. It is a symbolic link called XYZ. Think of it as like our desktop shortcut. So we have a shortcut in our desktop, and when we click that, it just goes and references to some files in some part of our computer, right? The concept is very similar. So you create a symbolic link here which nothing but references the original file. So what these two files does is, it just references to the XYZ, which is the symbolic link. So it just references the symbolic link, and the symbolic link is nothing but a representation of the original file. So why is this useful? Suppose there is a newer version ABC in V2. So what you can do is, you can create that ABC version 2, just delete this symbolic link and create another symbolic link between ABC version 2 and with the same symbolic link name XYZ, and you don't have to change anything in this programs. So because it still continues referencing XYZ, but instead of it representing linking to this ABC version 1, it is now symbolically linked to ABC version 2. So the only change you do is you delete this link and then create a new link with the same name. So by doing this, so you reduce the grunt work of doing it like 20-30 times. This is what they are trying to say. This is what they are trying to explain as symbolic link. And hard link, they say they will explain it in the next chapter. Summing up, with our tour behind us, we have learned a lot about our system. We have seen various files and directories and their content. One thing you should take away from this is how open the system is. In Linux, there are many important files that are plain human readable text. Unlike in many proprietary systems, Linux makes everything available for examination and study. Cool. Nice.